Okay, here we go. Greetings, folks. Uh, Hi, I'm Mark, for those of you who haven't seen me before. So last week I did my first ever live stream. It was not the worst thing ever. Made a couple small tweaks to the setup. Hopefully this week the camera will be slightly more stable. Hopefully the sound is working out okay. So the plan for today. Last time, bring up my notes here. So last time I was talking about the Redux Toolkit Action Listener middleware that we have in development. And I had hoped to get into some actual code last time. And instead I actually ended up talking for 2 hours straight, which anyone who knows me, this is really not much of a surprise. I will be doing some talking today, but the goal for today is really to get into an actual real issue that's been reported and really try to live debug this for real on the stream. Depending on your interest, this is either going to be more exciting or less exciting. So we're going to see how this works out. I'm still not intending to make streaming like a regularly scheduled thing, but I do have a few other things I would like to try showing at some point if this continues to work out halfway decently. So, the topic for today is the Reselect library. And so we're going to talk about a little bit about what are selectors, what is Reselect specifically, what are some of the changes that we've made to Reselect in the last few months, and then we're going to specifically dig into an actual issue that was reported and hopefully at least make a little bit of progress on trying to get that figured out. So let's talk about selectors overall. In Redux, we have a whole bunch of terms and concepts for different kinds of code that get thrown around. You've got reducers, which are functions that calculate a new state based on action objects in the previous state. You've got action creator functions, which are supposed to create and return an action object. But we've also got this concept called selectors. And while selectors are not something that are built into the Redux core library itself, they are a concept that has really been around since the very beginning of Redux. If you go back to some of the very early Redux issues, selectors were first mentioned probably around June 2015 or so. So right about the time that the early preview versions of Redux became available. So the Redux documentation has always mentioned this idea of selector functions. And earlier, somewhere in the middle of last year, as I've been slowly working on rewriting the Redux docs, I put together a much updated documentation page called Deriving Data with Selectors that goes through and explains what selectors are, why you might want to use them, and talks about this Reselect library specifically. So I'm going to skim through this page a little bit real fast, and then we'll jump over and look at some of the Reselect repository. So in both React and Redux, we frequently need to derive additional data from our existing state. An example of this would be we have our classical to-do list application. Some of the to-dos are marked as completed, and the user wants to filter the list to only show to-do entries that are completed, which would be a subset of the original data. So conceptually, we have two pieces of actual state that we're trying to keep track of. There's the original array of all of our to-do objects, and there's some kind of a current filter settings value, like show all the to-dos, show to-dos that are completed, and show to-dos that are not completed. So in our code, we can derive the list of just the to-dos that are completed by taking the original data and running like a filter, an array command on it, like filter or something like that. So that would be an example of derived data. You start with the original state and you run some calculation based on that. And you don't have to store this additional data because you can always recalculate it based on the originals. So a selector function specifically is a function that usually takes the Redux root state object as its primary parameter, may take some additional arguments as well, and is either going to extract and return some value from the original state, or it's going to derive a value from the original state. So we've got some examples here in the docs page. So a function that takes the root state and returns a single slice of that state could be a selector. A function that derives some values like return just the IDs of the items could be a selector. And there's really a couple different reasons why you might want to use selector functions. One is that if you're trying to actually access the Redux state in a component, the functions that you pass into the Use Selector hook are actually selector functions. They take the root state and they extract or return something. But you might also want to encapsulate the process of looking up some data out of the Redux store. For example, say that we have some very deeply nested field that we're trying to look up. We might not want to write that entire lookup chain all the time, because if we have that same lookup chain in many different places, then if that state structure changes, we might have to change all those different use places. So if we encapsulate that by writing a function that knows where to find that piece of data, then if we actually make a change to the state structure, we might only have to change the reducer, which manages how the state is calculated, and the selector, which knows how to dig in and find that piece of data. So while selectors are not a required concept in Redux, they are a level of abstraction. They're a very common thing to do in Redux applications. I kind of like the description that a selector function is like a query into your state structure. You don't know where we're going to find that piece of information. You don't care how we get that piece of information. I just call the function, pass in the root state, and I get back the piece of information that I'm looking for. Now, the other big reason to use selector functions is trying to optimize certain calculations. And the classic example of this is, let's say we're trying to extract something like the title or the ID from our array of to-do objects. And we might write an inline selector that says, take the root state, map over the array of to-dos, and extract to-do.completed or to-do.title or to-do.id or something. And this is a problem because array methods like map and filter always return a new array reference. And the Use Selector hook, whenever it sees a different reference returned by your selector than the last time, it will force this component to re-render. And the selector executes every time an action is dispatched. So with this particular example right here, this will force the list component to re-render after every dispatched action, regardless of whether any of the to-do entries actually changed or not, because it's always creating a new array reference. Another example is, what if the selector has to do some really complicated and expensive calculation work? Now, don't worry about what the actual calculations are here. I'm just kind of trying to illustrate the concept. Let's say that we take our initial state, we have some data in here, And then we run some really complicated series of calculations that transform the data in some way. And those calculations are expensive enough that we don't want to have to rerun them every time an action is dispatched. We really only want to rerun these calculations when the specific inputs that we're transforming get changed in the first place. So that's where this idea of memoization comes in. Memoization is a form of caching where we specifically look at the inputs to a function, we run the calculations and return a result, but we save the inputs plus the result for later use. And if we call that memoized function again, and we pass in the same inputs as last time, the function can say, oh wait, I recognize these inputs. I remember what the output was from last time. I'm going to skip doing all the calculation work, and I'm just going to return the saved result from last time immediately. So Reselect is specifically a library for creating memoized selector functions. And like I said, it's been around since 2015-ish. Strictly speaking, Reselect is not part of Redux, and you can really use it with any plain JavaScript data. You could use it even in a plain React app if you're not using a Redux store, but it is very commonly used in Redux applications. So Reselect has a primary function called create selector, and the idea is you write one or more input selector functions that take the Redux root state and extract some kind of value. You pass these input selectors to Reselect, either as individual function arguments or an array of all the input selectors. And when you actually call the generated selector function with the Redux root state, Reselect will call each of these inputs in turn, take whatever values those inputs return, and call this output selector with each of those values as its arguments. So in this example, I've created 3 different input selectors. I pass each of them as arguments. When I call the selector function with the state, it's going to call select A and save whatever that returns. It's going to call select B, save that, call select C, and save that. And then those 3 values get passed as separate inputs to, or separate arguments to this output selector function. It runs some calculation, returns a value, and we get that back. If we call this selector function again, it's going to rerun these input selectors, but then it checks to see, are all these extracted values the same as the last time it was called? And if all of them are the same, it will skip rerunning the output selector and just hand back the saved result from last time. Now, there are some things to be aware of with Reselect. Historically, by default, Reselect selectors have only had a cache size of 1. So if you call it multiple times in a row and you keep passing in different arguments every time, then the selector never has a chance to memoize properly, because every time we call it, it sees different values, and so it's always having to calculate a new result every time. So in this particular example, if I call a selector function 4 times in a row, the first time we call it, it sees the existing state and a parameter of 1, and it's going to run the calculation because it's never run anything before. If I call it with the same arguments a second time, then it says, oh, hey, I've seen those. Those are the same as what I had last time. I can reuse the previous result. If I call it with some different arguments, it says those are different than last time. I should throw away the old saved result, calculate a new result, and save that in case I need it again. And then if we call it with state 1, again, it says, well, state 1 is different than state 2. I'm going to have to throw out the last result and recalculate it again. So it's forgotten the earlier saved value from the previous state 1 calls. So that's the behavior that Reselect has had really since its beginning. There's a cache size of 1. You can pass in multiple arguments, but if you call it multiple times in a row with different arguments, it will never have a chance to reuse the last value because the inputs keep changing. So in early 2021, I believe, I posted a large discussion issue on the Reselect repository where I said, okay, the previous maintainer of Reselect has been busy with other things, and there are a lot of known pain points with Reselect at this time. The fact that you can only have a cache size of 1, some common cases like if I map over an array of to-dos and select the IDs, and then I dispatch a Redux action that flips the completed flag in one of the to-dos, the selector is going to have to recalculate because the input array is a new reference. But the array of IDs should be the same, but it's going to be a new array reference as the output, even though all the contents of the IDs is the same as before. And so that sometimes forces additional changes and recalculations downstream. So it'd be nice if there was a way to say, look, the contents of this array or object result haven't actually changed, like they're shallow equal to the last result. Let's just reuse the last result anyway. So I put together a really big article or discussion thread where I tried to talk about, here's all the things that people have complained about with Reselect. Here's other libraries in the ecosystem which try to address some of those pain points in some way. We should try to figure out some kind of like a Reselect version 5 API that tries to fix some of these problems. Does anyone have ideas for how to improve this? And there was some discussion, but the thread really never kind of got nearly as much interest as I was hoping it would have. So I was busy through much of last year, but in the fall, I had some free time, and I decided I was going to sit down and try to actually address some of these issues. And so I went through some of the existing pull requests and discussions, and I was able to pull together several different changes and make a few additional tweaks. And so I put out Reselect 4.1, the first new version in about 3 years. And this made several changes to the existing code base, and I'll skim through those hopefully fairly quickly. The biggest change is that Reselect has always had the ability to customize the memoization behavior, but it has a built-in memoization function internally. And that was the piece specifically that only allowed cache sizes of 1 by default. So I went in and I borrowed code from an existing memoization library out there, and I rewrote the insides of this default memoized function so that it now supports cache sizes greater than 1, and you can specify that by providing an option when you create the selector to specify a maximum cache size. And that's really another big change. Previously, in order to customize any of the selector behavior, you had to call this other function called create selector creator and give it your own custom memoized function or pass different options into the default memoized function. And then call that generated selector creator to actually generate the selectors that you want to use. So I changed it so that create selector itself now actually accepts additional parameters as its last argument. And so you can now pass things like a separate equality check function or a cache size or an equality comparison to use on the selector outputs as arguments. Additionally, someone had contributed or someone had filed a PR that tried to completely rewrite the TypeScript type definitions for Reselect. Now, at the time, Reselect 4.1, the code was written in plain JavaScript, and I believe I've got the 4.1 code up over here. So you can see the original code was all plain JS, and the type definitions were in a separate file. Those type definitions were not pretty. That type definition file was over 1,000 lines, and that's because it had handwritten overloads for one argument with inputs as separate function arguments. Like 1 through 12 separate arguments, 1 through 12 arguments as an array. Like, this is absolutely impossible to read or use. And this was written back when like TypeScript 2.7 was the latest version, I think. So TypeScript itself has changed a lot since then. And the new type definitions that a user had created tried to use some of TypeScript's type mapping features to say, we don't care how many selectors you pass in, we're just going to look at all of them and try to extract the type of each input function. So I went in and I took those new type definitions and I converted the code base to be actually written and built in TypeScript. And I applied the new type defs, and I was able to get this working and passing the existing type definition tests. So I put this 4.1 version out in October. 24 hours later, I had to put out a bug fix release because people immediately reported several problems with the type definitions. Several more type fix releases followed in quick succession. For example, users had reported that nesting several layers of selectors were causing TypeScript errors because it couldn't process all the nested calculations. We had cases where some of the parameter inference wasn't working correctly. Okay, more cases where the parameter inference, more cases, like it was, I felt like I was playing whack-a-mole for a while. So at this point, 4.1.5 is the last release. It's been out there for a couple months now, and it feels like things have mostly stabilized. I spent a lot of time scratching my head over the type definitions, a lot of time asking people smarter than me for help. The type definitions at this point are very, very complicated. I'm not going to bother trying to go through them because trying to explain them would be a multi-hour stream in and of itself. But the core of the current type defs is, where did you go? I'm looking at an output file, that's why. The core of the current type definitions is a type called merge parameters. And the idea here is you as the user passed in one or more input selector functions. Each of those inputs takes one or more arguments, like the Redux root state, an ID value, an object, something like that. The generated selector function that is going to be made by create selector needs to take a set of arguments that is the smallest possible type that all of those inputs could accept at the same time. And this ends up doing some very, very, very complicated type level transformations to extract the parameter types from all those input functions, shuffle them around, intersect the types at each index together, and then figure out what is like the smallest possible type that we could have at each position so that we can use that as the argument types for the actual function that is being generated. This type right here has been a work in and of itself. So this is all really, really complex. The good news is your application code shouldn't have to worry about any of this as long as you provide reasonable types for your input selectors. It should all just work. And as I'm looking at this right now, I'm remembering that I actually had a bunch of changes going on in this code base in order to try to debug some stuff, and we're going to have to ignore that for now. In fact, I may actually pull up the Reselect repo and stash and ignore those changes for now in case we actually have to make some code changes. So the idea is that your user code just ends up having to say, hey, my function takes an argument that is like a string or a number or a root state type, and Reselect should hopefully figure out all the details after that. So that's what we've done in Reselect 4.1. So you now can specify a cache size later than 1. You can now pass options directly as you call create selector, and we've improved the TypeScript types. So let's start talking about the bug that I'm hoping to actually investigate here in the next couple minutes. So a few weeks ago, a user filed an issue reporting that they were seeing some performance problems in Reselect 4.1.5. And they said, if we use 4.0.0, our app works fine. And they have some apparently very, very complicated selectors in their app. And when they tried upgrading to 4.1.5, they started seeing a whole bunch of performance problems to where the UI would apparently just about lock up in some cases. So we had some discussion back and forth, and the user showed some examples of memory usage graphs in the browser DevTools. We were going back and forth, kind of discussing a couple possible things that may or may not be related to the issue. They also provided a couple of screen captures of stack traces in the browser's JavaScript performance DevTools. So for example, here we can see when they ran a section of their code with Reselect 4, the stack trace is fairly flat. So I can see a selector function. I see a few different functions being run. But with Reselect 4.1.5, that same selector function with presumably no other code changes now has an extremely deep call stack. So clearly something is behaving very differently. And at the moment, I don't know what. The user also provided a couple other examples of some bits of the code and eventually put together, let's see, eventually did put together a repository that has at least a partial standalone reproduction of some of the problems, as well as some further information indicating that they narrowed it down to some of the code inside Reselect itself. So this has been on my plate to investigate for the last few weeks. Had some other stuff I was trying to do over the Christmas break. So since the user has actually provided a demo application that at least partially replicates the issue. My goal for today is to actually dive into this bug and try to get some idea of what is actually going on. Now, I've done a little bit of poking at this earlier today so I could get a couple pieces set up so I'm not totally wasting time on stream. But at the moment, I truly do not fully know what's going on with this bug. I have a couple partial hunches, but I really am going to be digging at this basically live. So I would actually like to figure out what's going on. If we get really lucky, maybe I can actually fix what's going on. But honestly, the goal for the rest of the stream is to kind of both show people what Reselect looks like on the inside, but also kind of show here's how I approach trying to solve and investigate issues like this. I guess sort of a here's how Mark works kind of a thing. Let's see. Chat's been pretty quiet since I got started. Looking over there, people still following me. We cool so far? Thumbs. Okay. Just making sure like I hadn't completely lost connection here and was talking to myself this whole time. Okay, cool. So, let's actually dive in. I will try to kind of keep sort of live talking my way through this, but if I look like I'm lost in thought, it's probably because I'm lost in thought and actually trying to look at things and see what's going on. All right, so I have already cloned the example repo that the user provided. Cloned it, installed it. I poked around the code very briefly. So let's take a look at the actual application in the browser first, and then we'll actually look at the insides and see what's going on. So starting up the app in dev mode, standard create React app, looks like it's create React app version 5, not that that matters too much. Waiting for it to build. Okay. So like I said, I did briefly poke around this a little bit, so this is not the very first time I'm seeing the app, but I really haven't dug around at it very much. So here's the demo app that the user has provided. We appear to just have a very, very, very stupidly large list with a whole bunch of list items inside. If we look at React DevTools, we can see, yep, we've just got an app, a timeline component, and a timeline item square. So this looks like a very standard large list of some kind. If we interact with this, what can we actually do? So I believe I can click on some of these list items to select them, and it shows some details inside. I believe I can click on an item again to deselect it, and if I hit next date, I think it ends up regenerating a bunch of fake data to show a next day's worth of items. So at the moment, if we look at the repository, the repo is already set up to be using the latest version of Reselect, which is the one that does appear to have a performance issue. And let's look at the code very briefly to see what we've got here. So we've got a standard Redux toolkit recommended folder structure. We've got our app set up over here. We've got a few different reducers. Counter is probably irrelevant. Yeah, that's the standard counter example that's just built into the template. We have a party slice. that generates some fake data for this demo. And we have a kind of an input selector that's going to take the root state and return this array of data. We have a reselect selector that uses this as its input, and it looks like it's just going to take the array and transform it into an object lookup table. Got another slice that does actually exactly the same thing, but just with a different type of data. And then we have a timeline slice, which has code to also generate entries that are ultimately being shown as all those list items. We have reducers to select an item, clear an item, and change date. Okay, those correspond to the UI buttons and behavior we saw earlier. Got a couple more input selectors to extract specific values from the timeline slice. And then we've got one other file that has some dedicated selectors in there. And this is probably kind of the more relevant area of the code for this reproduction. So here we have a fairly typical reselect create selector call. It's accepting 3 different input selectors. I will note that strictly speaking, we don't need this to declare the TypeScript types. Like if I remove that, TypeScript should actually infer all the different types correctly, and it should know what each of these extracted values actually are. Doesn't necessarily hurt to declare the types here, but part of the point of the type changes we made in 4.1 is that all these types would get inferred as long as these input selectors themselves are typed correctly. So this is taking a lookup table, an array, and a lookup table. We are effectively mapping over this items array and adding the body of the original item, looking up purchase entries with this item's purchase ID, looking up something else with this purchase ID. Okay, so we're taking the original list of entries, and we're correlating that with 2 other data types to pull together all 3 pieces that we would need for actual display. We've got another selector down here that's taking one of those arrays of combined items and converting that into a lookup table keyed by item ID. And then one thing I noted with the discussion in the issue earlier is they are also using a library called Reselect. And that is a wrapper around the original Reselect library. Remember that I said earlier that up until just a couple months ago, Reselect selectors only supported a cache size of 1 by default. But because the memoization capability could be swapped out or customized, this Reselect library was created to try to let you make one selector function that could have a much larger cache size inside. And the idea is that you specify a function that returns some unique key out of the extracted data, and then it will store the cached result for that key. And if I call the selector again with different arguments and it extracts a different key, it will also save the other cache result as well. So the idea is you can increase the cache size by storing unique cache results for each extracted key. So they are apparently using this Reselect create cache selector function inside of their code base. And so here we can see a usage where they're passing in a pair of input selectors, a timeline purchases by ID selector, and then something that extracts just the ID of the current item. They are using that item ID as the unique cache key internally to this multi-item selector. And then if we look at the rest of the code base, we can see that this Reselect based function is being used inside the list item component that represents each of those rectangles that we saw on screen. So they're calling the standard use selector hook. This is actually slightly unusual. They're using the function keyword to create the selector that's passed into use selector itself. But then they're calling that multi-cache key selector with the current state and the current item ID from props. So that's what the code on this actually looks like. So we've got some nested selectors. We've got an example of the Reselect library being used, although based on some of the stack traces that were shown earlier, I don't think that Reselect is specifically related to the root problem here. And it seems as though something is recalculating far too often, or at least it's taking too much work to recalculate things inside of Reselect itself. So let's pop over briefly and look at the actual implementation of Reselect 4.1, and then let's actually dive in and see if we can figure out what's going on. So Reselect 4.1, the code really currently consists of 3 files. Default Memoize has the standard built-in memoization function that will get used if you don't specify anything custom. And as of 4.1, this is where the multi-cache size logic that is internal to Reselect is actually implemented. I actually borrowed the code from another library called LRU Memoize. The author of that library is actually the same person who made Redux form and React final form, if you're familiar with either of those libraries. We have one file that is nothing but TypeScript types, which doesn't concern us here because we care about runtime behavior. And then the actual core logic is still implemented in index.ts. So let's skim through this real fast. There's a function called GetDependencies, and this is supposed to look through all of those input selectors that you passed in. And what it's trying to figure out is, okay, create selector accepts either multiple input selectors as separate arguments or a single array containing all those input selectors. So this has the bit of code that figures out, well, are they inside of an array or are they separate arguments? Let's figure that out either way. Create selector creator is actually what we really think of as create selector for the most part. It accepts a specific memoization behavior function and some options for that memoization function if you want to provide them, and some function that needs to actually be memoized. I'll be honest, this function still kind of hurts my head when I look at it, so I'm not going to try to explain every nuance of behavior here. But given those customization aspects, it's going to make the function that we actually know as create selector. Create selector itself accepts 2 or more functions as arguments. We have some careful dancing around looking at possible options that the user may have passed in. And eventually we're going to use the memoization function that we were given. We're actually going to use it twice. And to be honest, this is a bit of implementation behavior that was there before I started messing with this code at all. So I'm not fully sure I still understand exactly why the memoization function gets used twice. So it gets used once to wrap the actual result function or output selector. And this is that final function that you provided that actually takes like A, B, C, and returns the result. And we have a little wrapper here so that it can keep track of how many times we actually had to recalculate results, because you can ask the selector, how many times have you been recalculated? We also end up calling memoize again, and here it's really concerned with looking at the arguments that were passed in, calling each of the input selector functions that you provided, and then extracting those and forwarding them to the function that does the actual calculation. So I think the idea here is if you literally pass the exact same arguments to the selector twice in a row, it will skip running this check and even bothering to call the output selectors. If you passed some slightly different arguments, it will go to the effort of calling each of the input selectors, but it's possible that the values they extract could still be the same as last time. And so that double layering means that in some cases, we can skip running the input selectors. And even if the input selectors run, maybe we can still skip actually executing the output function. So I think I actually just explained that to myself now that I'm talking my way through it. This is wonderful. So you'll notice that we're using the exact same memoization function at both levels, at the parameter input selector check level and at the actual execute the output selector function level. Okay, so let's actually dive in. I've already managed to burn an hour already talking, and I said I was going to try and do actual more code stuff. So here comes the unknown part where I'm actually going to look at this and feel very, very confused as I look at things. I have a few different things I want to try as I go along, but yeah, this is the part where I actually explore and scratch my head a lot. So the first thing I'm going to do, the user did actually provide a couple of Chrome JavaScript performance profiler traces. We saw a couple screenshots of these traces over the issue. So I'm going to open up both of those profile captures, and I'm just going to sort of skim through them a little bit to see if anything very obvious stands out. And I'm going to see, can I zoom in the dev tools themselves? Yes. Okay. I did glance at these very briefly earlier, but I've not tried to go through them in depth. So this is the profile for their actual for real application using Reselect 4.0. So if we look at this area of the timeline, we can see there was a lot of calculation going on, like an entire second's worth of calculation. Wow, that's not good. So if I start looking at this area, I can see a lot of areas that this looks very React to me. Like I know that perform sync work on root is a React internal for function. Dispatch event. This is likely going to be a React event handler of some kind. Let's see, we have handle single click. That sounds like a click handler inside of a React component somewhere. We have a dispatch function and a handle change wrapper. I recognize these as being part of React Redux Connect internals. Actually, scratch that. Not necessarily Connect. Handle change wrapper is part of the internal subscription class that we have in React Redux. So here we're getting down to a section where we actually have some Redux stuff going on. And we have, okay, this really does look like it's probably using Connect internally, because Connect has to do this whole cascaded series of notifying nested connected components that, hey, the store has been updated. You now can look at the updated data. So the fact that I see a whole series of handle change wrapper functions in here tells me that this is almost definitely some Redux connected components rather than use selector. Yes. Pure final prop selector and map to props proxy are both definitely part of Connect. So we've got some Redux stuff going on in here. Can we identify where they were showing some of their actual code? So they were saying it's a get calendar square from calendar function. I don't think that this panel, I don't think that the performance panel has an, can you, let's see, let's find out. Can you search for a function by name in here? No, that would have been entirely too easy. Okay, we're going to have to eyeball this. Okay, we know that they're calling it from a use selector. So apparently they have a mixed code base that is partly connect and partly use selector. And then there's some more class component stuff. It's not in that area at all. Whoa, there's a lot of stuff going on over here. More connect, a lot of connect. It's quite possible that because Reselect is at, ooh, here we go. This looks more promising. There's a use selector. Ooh, I think we may have found something. Flex slots row list square, use selector, calendar square, use selector. That's promising. Okay, this looks like what we're looking for over here, I think. In fact, this looks like the area that the user screenshot right around here. Okay, cool. Okay, so the actual execution time here was less than half a millisecond. That seems like generally a good thing. And there's a get function, register cache hit, and delete cache hit. I'm guessing these must be part of Reselect. Okay, yes, that is a Reselect based function. Okay, let's look at the code with 4.1.5 running. Trying to zoom out. Oh my, this does not look like a good thing. Holy smoke. Look at this. Oh my word. Okay, yeah, this is decidedly bad. Oh my word, look at that. Okay, so for one instance of that component, the selector is taking 15.5 milliseconds to run. And we can see that there are many, many instances of that component that are having to recalculate right now. That's not cool. Selector, memoized, anonymous, memoized. Okay, so we get through a whole bunch of levels of detail. This probably represents a series of nested selectors. So like they defined selector A like that. Like, okay, yeah, so we've got some input selectors. There's like this right here probably is made up of several selectors itself. So in order to get down to the actual calculation logic, um, it's probably having to work through several layers of selector functions in the first place. And so that probably represents, or that's probably what these represent. So here we get down to a lot of actual comparison logic. So this stuff I'm more recognizing from some of the Reselect internals, I think. Like our arguments shallowly equal is yeah, that's a function that's right here inside of default memoizes behavior. So at this point, we're definitely down inside Reselect 4.1.5. The fact that we're calling an is equal function and a base is equal deep is very disturbing because that's not built into Reselect. Because the standard behavior is to just do strict equality checks. So this makes me slightly suspicious that a little bit of what's going on here is they are using a deep equality check function rather than a strict reference equality check function, because that looks like it's clearly a lot of the cost in here. If we look over here, Okay, I'm not seeing any indication of equality check customization in their code. So I've never really looked at the guts of Reselect before. I know what it's doing at a high level, but I haven't really tried to see what it's doing specifically. So let's go investigate Reselect for a minute. So they're calling create cached selector, passing in a function that extracts some value to use as the cache key. And this cache object is an LRU object cache with a size of 1000. So Reselect. Okay, the index file is just re-exporting things. So what matters is create structured cache selector, blah, 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 blah. Okay, so this is fairly similar to the index file in Reselect itself. Okay, so here we have the actual generated selector function. It takes whatever key function you gave it and extracts a cache key. Checks to see if it's a known cache key and then tries to check to see if that item's in the cache. A couple other cache-related things. Okay, let's see what that LRU object cache thing is. So it's class, where we can get, set, remove, clear. Do we have anything that resembles an is equal function in here? Okay, no code. Is the word equal here anywhere in this code base? Not in the actual code. Interesting. So I'm very curious where we're getting something that appears to be a deep equality function, because Reselect certainly doesn't use one of those by default. And I don't immediately see any evidence that Reselect uses one of those by default either. So that is making me wonder if perhaps the user that reported this is doing some selector customization somewhere in their own code base and making, I strongly suspect that it's the is equal function from Lodash. But again, like neither Reselect nor Reselect use that by default. So I have a suspicion that the user is creating a customized version of a selector somewhere in their code base that does some deep equality checks. And the deep equality checks certainly account for some of what's going on here, but they don't explain why there's this many levels of nested memoized functions going on. So that's a little bit of a concern. Okay, so thus far we've looked at a 4.0 perf trace, we've looked at a 4.15 perf trace. We can see that indeed something appears to be very, very wrong with a 4.15 perf trace. So for point of comparison, let's go back to the demonstration app that we've got, and let's try capturing a perf trace ourselves within the demo app and see if we can get anything that looks at all like any of those stack traces or perf traces. Okay, so let's see. Performance. Start profiling. And I'm just going to click through a few of these list items. Click next. Okay, and we'll stop there. Okay, so let's look at a couple of these and just see if any of the perf traces bear any resemblance to what we were seeing in the real application perf trace a minute ago. Okay, so presumably each of these is a click handler. So if we scroll down through here, got okay, we've got a bunch of different components in here. You know what? It would probably be a good idea to do another side-by-side comparison. So what I'm going to do, I'm going to save this perf capture. I'm going to save this perf capture as uh, example 415.json. And I'm going to drop back here. And I'm going to temporarily alter the application so that we use Reselect 4.1 instead. And then we'll try doing another perf capture so that we can look at the demo app perf captures side by side. Okay, and just to confirm, if I look at node modules over here, okay, good. That should be the only version of Reselect in the code base. And actually, just to confirm that we really only have one copy of Reselect, let me look at the Redux toolkit folder. I don't see any nested node modules under there. So yeah, we should be using only Select 4.0 this time. So we'll restart the demo app. And it helps if I actually run yarn start instead of trying to reinstall things, doesn't it? Wait for the application to start. Okay, we'll capture another performance trace. I'll do the same kind of thing. Click, 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 deselect, next page, click, click, and stop. Okay, and we will save this for later reference. Okay, so my copious numbers of windows here. So this one has 4.0 open. Oops, I just loaded the 4.0 one twice. Okay, so we've got our 4.0 and 4.15 performance traces from the demo app. So let's zoom in on a couple of the 4.0 clicks. Let's see what we got down here. Okay, so this one is 0.6 milliseconds. Got a few layers of anonymous and a single R arguments shall we equal call down here. And for comparison, if we look at the 4.1.5 example, and we look for something kind of similar. Okay, I'm not sure this is necessarily telling me a whole lot at the moment. Yeah, actually I take that back. That looks... That looks different enough to be slightly suspicious. So in 4.0.0, I'm seeing a series of functions that are just labeled as anonymous. And in 4.1.5, I am seeing an alternation between memoized anonymous, memoized anonymous, memoized anonymous, which at least partly suggests this looks kind of like that pattern we were seeing in the real application. Okay. Let me look at the Reselect code again for a minute. All right, let's try this. So one thing that's not entirely helping here is all these anonymous functions. It would be, I think we have a halfway decent idea what they are. Like there's only so many places in the Reselect code that have functions like that, but it would be nice if we could distinguish these a little bit. So here's what I'm going to do. So I have the actual Reselect code right here. And we can see right now that we've got a couple functions buried down here, which probably are those anonymous functions. So what I'm going to do is I'm going to create a local customized build of Reselect. I'm going to give these functions names, and then I'm going to install this customized local Reselect build into the example project and try capturing another perf trace just so we can see if we get a little better idea of what the sequence is here. Drat, now I have to come up with names live, and we all know how hard it is to come up with good variable names. Let's call this one recomputation wrapper, and let's call this one dependencies checker, for lack of any kind of a better name. And is there anything else in here? No, I think it's probably just those two. So this actually is about to be a useful bit of my workflow that might be helpful for folks here. So I frequently want to test out in-progress versions of the libraries that I'm working on. And the traditional way to do that is to use the npm link command, or yarn link if you're using yarn for package management, which is supposed to create a symlink from the library repository into the node modules folder of whatever application repo working on. And a lot of times this frankly doesn't work out very well. This is actually a common cause of the React can't have more than one version of React at once error, um, and stuff like that. So I found a very, very useful tool for this called Yalk. And what Yalk does is it lets you do a true publish of whatever package you're working on, like actually runs the build steps, zips up the tarball, everything else, but it saves that published package to a local cache folder. And then you can go to an application and type in Yalk add name of that package, and it overrides package.json, extracts the tarball into a dot folder, and then you rerun yarn or npm, and that actually then copies that extracted file into node modules so that you've now effectively installed the local build of the library into that project, and you don't have to worry about symlinks or duplicate React versions or anything else. So I ran across this years ago, and this is a very, very big part of my workflow whenever I'm wanting to test out packages. So I'm going to say Yalk publish, and this will take a minute or so to do its build. Decompile some files. Okay, so Yalk now has the local only build that I just made. So I can come back here to the project folder and I can say Yalk add Reselect. It says it's still 4.1.5 because that's the version in package.json at the moment. If I really wanted to make this more clear, I could have changed it. So if we look at the example repo folder, we can see there's now this .yalk folder in there, which has Reselect inside. And we can see that these are the actual published artifacts from Reselect. And if we look at package.json, I will remove the override that was forcing it to use 4.0. And we can see that in the dependencies section, it's now saying that, hey, Reselect is actually in, the source of it is in that .yalk folder. So if I rerun yarn to actually update node modules, then yarn will say, oh, I should grab the files from the Yalk folder, copy them to node modules, and use that as the installed version. And so I can confirm this. If I come into node modules, and I go all the way down to Reselect, and if I look at the actual output code, oh, hey, look, there's the function that I just renamed. Wonderful. Okay, so now the example app has this local build where those formerly anonymous functions now have actual names. So we'll restart this. I have traditionally preferred using Chrome for its actual development tools and debugging to JavaScript, but I've always been a Firefox person for actual browsing. Okay, let's go capture another perf trace. Let's see, this still has the entirely too many tabs open. Okay, I think this was the 4.0 one. All right, so we're going to start capturing. Click, 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 deselect, next, click, click, stop. Save that as 415 named funcs. And let's see if we can actually find and get a better idea of what's going on with that stack trace. Ah, look, we actually have function names now. How wonderful. Selector, memoized dependencies checker, memoized dependencies checker, memoized dependencies checker, memoized. Okay, what is this actually telling me? Part of me thinks that this is still probably just that there are several selectors nested together as inputs to each other. I'm not necessarily convinced that this is a performance bug in and of itself. Part of me is almost tempted to go back to the Reselect source code and like start generating random IDs and attaching them to the function names. If there's actually some way to do that, probably not worth worrying about right now. Just to try and get an idea, like, are we calling the same functions over and over, or are we calling separate functions in these cases? Okay, so we've dug around here, and I'm not necessarily a whole lot closer to actually figuring out what's going on here than I was when I started. We've confirmed that something's very clearly different between 4.0 and 4.1.5. We can at least see which of those two anonymous functions is getting executed. It's the dependencies checker function. Let me go back and look at the actual application code for a minute. So this was in the timeline item square component. So we're calling select timeline item selector. We established that was being generated with Reselect. It's taking a couple of other memoized. Is this memoized? Okay, that one is not memoized. That one's not memoized. This one is. So there's at least one other level of input selector that is memoized. And okay, yeah, there's at least a couple of different levels of memoized selector functions here. So I think that explains why we're seeing some of that nesting there. Okay, so I'm going to switch up tactics at this point, and this is actually something I wanted to try during the course of this exercise anyway. So this next section is somewhere between me exploring things and also an unsolicited plug for a product that I find interesting. So I've recently been looking at something called replay.io, and this is a time-traveling debugger that was started by some folks who used to work on the Firefox DevTools. And the sales pitch here is that they've created customized versions of browsers that have the ability to record everything that happens inside the browser while your app is running. The the JavaScript execution, the network requests, the event handlers, literally everything that happens in the app. And then it can export all that saved interaction information, upload it to the cloud, and they give you a way to step back through the application kind of step by step. And you can add logging and debug information after the fact without having to have had that information there in the first place. So I've already downloaded Replay, and the Replay application itself is basically a customized version of Firefox. So I'm going to load up the exact same application that we were just looking at. And rather than doing a performance capture this time with the browser's own built-in DevTools, I'm going to go ahead and record a replay capture, and then we're going to try and poke through that and see if we have any better idea of what's going on. So I'm going to hit start recording. And for the record, I have tried doing this a couple times prior to this stream, but I'm still fairly new to using this, so I've got a little bit of an idea of how to use it, but certainly not an expert at this point. Okay, so again, we have click. I will notice that the application does seem somewhat laggier at this point. Click, click, deselect, next. Yeah, definitely running a lot slower, and I'm not sure how much of that is Chrome versus Firefox and how much of it is the fact that everything about the browser is being instrumented. Click again, and stop. Okay, so the Replay Customized Browser has captured all that information, and I'm going to save, 65 megs. Okay, there's clearly a lot going on inside this thing. So we'll wait for this to upload. Chug, chug. The joys of watching a progress bar go further. Clearly there was a lot going on inside that application. Come on, almost there. Note for reference, a percentage indicator would be wonderful here. I know we've got a couple of replay folks hanging out on the stream. Actually, that's a great question. How many people do we have? 15, 20-ish. Okay. Okay, cool. So, the Replay browser has finished uploading this to the Replay servers. If I wanted to, I could switch over to a different browser and actually log into the servers and do the investigation part, but I've already got this open, so I'll stick with this. So again, like I've poked around the Replay UI a couple times, just long enough to have a halfway decent sense of what's here, but still fairly new. So over here, we've got some basic metadata about what I just recorded, the fact that it was me, 2 minutes long, permissions, URL, but then we also have some information about the actual user interactions with the app. So we've got two main sections. There's a viewer section and a DevTools section. The viewer lets me actually visually play back what we saw as I was clicking around in the browser earlier. So we can see, yeah, here's what was actually on screen as time went by, and you can see the highlighting as I clicked. You can see some indications of each of the events that happened in the app. But probably the more interesting section is this DevTools section. So what we've got here is kind of a mashup of some of the viewer area and your standard browser DevTools source debugger area, as well as a browser DevTools console area. So I could go digging through the actual source code for the application. So let me go down and look for that selector that we know was executing. And as I mouse over each of these lines, Replay has recorded exactly how many times each of these different lines actually got hit. So right now, I'm mousing over the body of the output selector right here. And it's telling Replay is telling me this got hit 7 different times. And if I hit the little plus button, it gives me the ability to customize some console logging behavior, and then it's going to execute that console logging as it would have happened every time that line of code got hit if I'd had that logging there before I even started running the app. So we're looking at a recording, but I can go back and add log tracing after the fact and see what's going on. So the default logging is just to say, here's the file and the line number. But it also shows us some indications of how many times this got hit and where in the timeline those line executions actually occurred. And so if I actually hop back and forth between these different hits, it's now like I've got the debugger paused at a break point, and I can actually see, okay, it looks like selected item ID is undefined. I can actually see, for example, like timeline and purchases by ID, and I can actually inspect the objects and the parameters and the data at that point in time. Or if I come in here and I say selected item ID and timeline and purchases by ID, and I actually capitalize everything correctly. I said if I actually capitalize everything correctly, which clearly I'm failing to do. Okay, so it's rerun the updated logging statement at each of the 7 hits that occurred for this line. And I can see that we're going back and forth between okay, so this is interesting. Let me go back to the code and make sure I understand how the pieces are actually fitting together here. Okay, I may be looking at the wrong function right now. So it looks like this function is what's used in the list parent component. And this function is the one that's actually used in the list item. Okay. All right, so maybe we should remove that. And what we care about is here. Oh my, 4,000 hits. Okay, well, that's clearly a lot more. By the way, also note for the replay folks, I've noticed this starts to choke when you have like 1,000 or 4,000 line hits. Clearly there's some perf limitations here. And I don't know if the console is. In fact, the fact there's a little warning sign here suggests to me that it's probably not going to let me actually do console logging because there may be just too many hits entirely. I'm going to guess there's a limitation on number of hits before it gives up on doing console logging. But we can step through some of the hits one by one and see what the input parameters are. Can we jump ahead somewhere random in the timeline? Yeah, comment from the chat. We won't try to console log that many. Okay, so I've jumped ahead to a random spot. The inputs here are let's see, will it actually try to tell me what we've got here? Maybe, maybe not. I suppose I should also ask, will it actually give me the ability to inspect the actual values at the time if there's 4,000 hits? Because at the moment I'm not actually getting any kind of a hover pop-up here. Okay, so clearly, ultimately what this is telling me, regardless of what the actual values are, is that this is running way, way too many times. So it might be worth looking backwards a little bit. So this takes timeline and purchases by ID selector as an input. So how many times is that re-executing? Interesting. That only ran twice. Okay, that's interesting. So this function, which takes this big array of data and converts it into a lookup table, only ran twice, and that's what's being passed to create cache selector. Creates cache selector takes two inputs, that lookup table and an item ID. Okay. Let's see if we can go find Reselect. Okay, so I've now got the published version of Reselect's index file open in here. And can we start getting some indications of how many times this stuff reran? A lot. Suspecting that's a lot more than it really should have been running. What about here? failed. Okay. What does for the replay folks in the audience, what does failed mean? Is that just like more than 4,000, or is it like they're actually something breaking at this point? And the answer is, we don't know. We're going to take a look. This is what happens when someone tries stuff out for live. Okay. Well, if this line ran 4,000 times, then we know that that this section ran at least 4,000. Perhaps it might help if we go back to the example app and we cut down on the number of fake list items being generated, and we do it with like 10 instead of like 2,000 or whatever the number is. So now I got to figure out. That looks like a likely candidate right there. So let's just change that to 10. And let's go back to here, refresh the page. And I'm going to make a brand new recording with only 10 items, and we'll see if that gives us a little better information. Click, 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 next, click, stop. And I see that it's uploading faster this time. Maybe I should have done that in the first place. Okay, so let's go open up. Oh, how handy. Did it actually preserve what files I was looking at between like a couple different runs? That's nice. Okay, so now if I look in here, okay, recomputation is 33. That's a much easier to deal with number than 4,000. And oh, that's interesting. Huh. So we actually recalculated the real final results 33 times, but we still had 350 hits to needing to double check whether the input selectors changed things at all. Interesting. Okay, can we start actually printing stuff here? Maybe. Okay, clearly it's having all kinds of fun trying to evaluate 350 items in a row. In the meantime, can I inspect this at one point in time? Yes, yes I can. Okay, this is looking a little better. So the dependencies at this point, this random spot, was a function called purchases selector. And the extracted parameters was an array of 1,000 items. Wonderful. A purchases selector. Oh, okay, that's the one that just flat out returns some items, and yes, it's generating 1,000 items here. Okay, that part's not a big deal. Let's see if we keep going through this a little bit further. Another hit. We've got parties selector. Okay, here's another example here. We've got something that had 3 input functions. Yeah, at this point, we're starting to get down into where I'm really, really, truly scratching my head and trying to understand what's going on here. I will note that it's almost 5 o'clock Eastern, and 2 hours is probably about long enough for anyone to listen to me talk at all. I definitely don't have any real answers as to what's going on here. I have a couple of vague suspicions. Part of me is wondering, I should go back to the original Reselect source. I'm a little surprised that we're actually getting into this area of the code that many times. I sort of would have expected that because it's trying to memoize this function right here, which looks at the arguments being passed in. Actually, you know what? Maybe that's part of the issue. I should be looking at arguments, not dependencies. Yes, yes, I can totally make this replay public. In fact, let me actually do that right now. Okay, done. Let me look at this for just a couple more minutes, and then we'll probably wrap things up here with me still scratching my head and not actually having any real answers here. So let me actually look at the arguments values that are coming through here, and actually let's just remove that because clearly it's not going to print out all those answers. So I am curious about the number of times we got to this line of code. And I would kind of like to know what were some of the arguments each time. So in this case, argument 0 was clearly the Redux state. Argument 1 was the number 1. Okay. If I go to the next time we got down here, the first argument was the state, and the second argument was also the number 1. Okay. Other question for the replay folks hanging out in the chat. Is there a way to see the actual literal stack trace at that point in time, just like you would over in the side panel of a browser DevTools? Because that would be kind of handy to jump back and forth in the code and see what the values were. Okay, I'm hearing a yes. Left sidebar, the little Ooh, there. Oh, this is wonderful. Thank you. I did not know that was there yet. That was a real question and some very helpful. Okay, now we're talking. Okay, what do we got here? Oh, and by the way, I will say, especially since a couple of you folks are ex-Firefox people, the work you did to be able to recognize common libraries like React and Redux and black box those stack traces, wonderful. Like I said, I still normally use Chrome for my day-to-day debugging, but that's a really cool thing, and that would actually kind of like I'd forgotten that was there, and I really should go back and like reconsider using Firefox for some debugging on occasion because that's cool. Okay, what kind of actual stack trace do we have here? All right, so let's take a couple minutes, and it is 5 o'clock Eastern now, so I probably will call this fairly soon. But let me at least step through stack trace just a little bit and see what the arguments are and what kind of stuff is getting passed through, just so I have a little better understanding of what's actually happening here. So, so we're starting up here with the standard React Redux notification code. We get down to where we've wrapped the selector and we're calling that, ooh, nice. We can actually see real values being passed in. This is wonderful. So we're calling it with state and for to begin with. So now we're into Reselect. And so the function called selector is what was generated by the Reselect library. And we've got some arguments here. The cache key is 1. Really? How do you get a cache key of 1? The item ID is 4. How is this thing actually calculating cache keys? Okay. Either I'm looking at something that I didn't expect, or I'm really confused how we're passing in 4 and extracting a cache key of 1. Select timeline item selector, parentheses underscore item ID. Okay. Yeah, that's pretty clearly that. Okay. Scratching my head on that one. I totally would have expected cache key to be 4 here. I'm not sure if this is something I'm not understanding about the Reselect library, if replay is confused, or if there's a bug in the code somewhere. Anyway, so Reselect is going to jump into inside of default Memoize. Why are we jumping inside of default Memoize? Is this using default Memoize somewhere? Selector creator. Okay, slightly confused at what I'm seeing with the call stack here. So we're inside default memoize. And okay, let me remind myself what the actual reselect code is trying to do here. Okay, so the default memoization function is what wraps your actual function, and it says loosely, if the inputs look the same as what we saw before, return the cached value that we kept around. As of Reselect 4.1, it now has the ability to either track just a single cache value internally or multiples. And we have to be using the single case because this user isn't using the max size caching option in Reselect itself. They're using the Reselect library for it. So here's that function called memoized that we were just looking at in play a minute ago and that we've been seeing in all these different stack traces. Very, very suspicious about why we would be jumping into that function this early. Zoom this in so the font size is ever so slightly bigger. So this is the Reselect code right here. Selector is the function that actually gets handed back to the application logic. Args is whatever parameters we're passing in, like state and item ID. Cache key still confuses me. Oh, look, we actually have a full standard break debugger step functions here. Oh, this is wonderful. Okay, what happens if we throw a pause here and we jump to one of the spots this gets it? Oh, including step backwards, someone is telling me. Okay, this could be all kinds of fun. Okay, so we are attempting to jump to one of the spots where it was instantiating a selector internally. Hopefully. Okay. Oh, okay. I truly did not until 30 seconds ago realize that you've got a full-blown debugger built into this thing too. I was very focused on the console printing statements. Oh, this is wonderful. Okay, so at this point in time, functions are an actual selector, the parentheses item ID cache selector, and an output function. Okay, that makes sense. Step in. Okay, so it truly is calling create selector there. That makes sense. So we step over some slightly hard to read compiled code. past all the arguments here. Sort of. I think the JavaScript debugger was just getting caught up on declaring a bunch of new variables there and kept hitting that line over and over. You know what? I don't care about looking into this right now. Let's go back out. Actually, let's go back to here. And at this point in time, handy. We've got arguments over here. All right, it's 5:10, and I've been at this. Well, I've been live for 2 hours. I've been debugging for over an hour, and clearly this is the area where it's going to take a lot more focused time to actually figure out just what's going on here. Part of me thinks that this may be a little bit due to that Reselect library and how it's using things. I'm a little bit suspicious that it seems to be jumping straight into default Memoize in some cases. I would have expected it to go through a couple other functions in between. So yeah, overall, clearly I don't have any full answers here, or I'm not even sure I have any bad answers either. And this is something that's going to take me a while to try to figure out. But if nothing else, at least you got to see, here's what Reselect is. Here's what's changed in Reselect 4.1. You got to see me messing around with my local dev environment, using tools like Yelp to publish local builds of an application, doing some performance profiling with the Chrome dev tools and looking through some of those pieces, and learning how on the fly how to use replay to actually inspect some of the recording that happened and dig through that. So no actual resolution today. This is not terribly surprising. I would have been a little bit surprised if I'd actually figured out exactly what's going on. But I think I'm starting to assemble some building blocks that can hopefully help me figure this out as I keep digging into this one. And in case you can't tell, and again, this is a entirely unsolicited plug, I've been excited about replay as a possible tool for a while. I just hadn't gotten around to adding it to my own list of things that I use regularly. And now that I'm actually getting hands-on with it and seeing that it has things like not just the the retroactive print statements, but also the full-blown standard browser step-by-step debugger, I can definitely see how this would be a useful tool for trying to figure out some of these issues. So I think I'm going to go ahead and wrap it up about now. I'd like to thank everyone for coming out. Real fast, does anybody have any questions or comments or anything else they would like to toss out or ask before I actually hit end on the stream? Give it about 15 seconds, see if anyone actually has anything else to say. Again, and so yeah, definitely thank you all, you folks, for showing out, for coming out and watching. Thank you to the replay folks specifically who popped in and were able to give me some advice on how to actually use this tool properly. Honestly, the next time I work on this, I'll probably just work on it by myself so I can actually focus a little better and see if I can really figure out what's going on. Honestly, most of the issues that I work on are not this complicated. Most of the stuff tends to be a little more obvious, although I guess in the case of some of the TypeScript stuff, not so obvious. Um, but hey, I'm a big proponent of having as many tools in your toolbox as possible, so that you can try and pull them out if the situation calls for it. And I think I've just managed to add a couple extra tools to the toolbox. So, all right, going to go ahead and call it here. I don't have any particular estimate for when I might do another stream. I've got a couple other ideas for different topics I might want to cover, like looking at the guts of React Redux version 8 and talking about how we changed the implementation of that compared to like version 7. Um, no, but not really sure when I might go ahead and try and do another stream like that, maybe in a couple weeks or so. Um, but keep an eye on Twitter, and I'll try and give like about a day's worth of heads up before I do that. And I have been, let's start that sentence over, shall we? I put the recording from the previous stream on YouTube. I will put this one on YouTube tonight or tomorrow. So if you do want to go back and watch things, they should be up there permanently. So yeah, thanks everyone for coming out, and enjoy your weekend.